Hey everyone, today we're going to discuss about the areas under the normal curve. So last time we've learned about the z-score and we've learned how we determine how many standard deviation a particular score is away from the mean. This time we're going to get the area under the normal curve. Remember in our previous discussion, the area under the normal curve is 1. Then we also have the center here. The center here is the mean, where the z is equal to 0. And also remember that the normal curve is symmetric to the left and to the right. Therefore, the area on this left side here, the left side of 0, is 0.5, as well as the area on the right side of the z equals 0. That is equal to 0.5. So what we're going to do is we're going to determine an area in between two particular z-scores, or to the left or to the right of a z-score. So in order for us to do that, we have to use the table of areas under the normal curve. Here's an example of the table of areas under the normal curve. This is also found at the appendix A of your book. So here are a list of numbers, and the corresponding z-scores are on this side here. On this first column here, we have the z-score for the first two digits, so the ones digit and the tenths digit, and this is the z-score for the hundredths digit. So if example, we'd like to know what is the area for 1.13, so we look at 1.1 and we look at 0.03, and there's the area. So this is the area for 1.13. Now, how do we use this table of areas under the normal curve? So the table of areas under the normal curve make use of the area in between 0 and this particular z-score here. So the areas listed here are the areas between 0 and the z-score. So it follows this particular diagram from 0 up to this z-score here. If we're going to check the negative values of z-scores, we just convert it with negative and it still works the same way. But remember that the area is from the z-score towards 0. So if it's on the negative side, it's from here going towards to 0. So that's how we apply that. So let's have some area. Remember that an area under the normal curve is a graphical representation of percentage, proportion, or probability. A percentage is used when reporting about the proportion, and the probability is used in talking about the chances that an event occurs. So let's have some examples on how we get the area under the normal curve. And then let's interpret on how are we going to, what the area means. So let's have this example here. Let's get the area of the area between 0.75 and 0. So let's take a look at z-score. So let me put here an equal sign. So you should have this one. So z is less than or equal to 0.75 or greater than 0. So it's somewhere right here. So 0.75. So we are going to look at the area between these two. So this is the area that we want to obtain. So we can get this using the normal curve. So this is the table of areas under the normal curve. We look at 0.75. So we have 0.7 right here. Then we go towards 0.05. So this is 0.75. That is 0.2734. You can check out your book and try to see if we're on the same page here on the area. So this is 0.75. That area is 0.2734. Therefore, the area between 0 and 0.75 is 0.2734. So let's write it down here. 0.2734. So this is the area of this region here is 0.2734. What if we'd like to obtain the area of z in between negative 1.2 and 0. Sorry, it should be on the other side. So z is greater than 1.2 but less than 0. So 1.2 should be somewhere right here. So negative 1.2 to 0. Take note that the area still goes towards 0, so we can still make use of the normal the table. But instead, what we're going to do is we convert this into negatives. So this is still usable. Remember that this table is usable as long as the area is going towards 0. So this is negative 1.2. The area that we are looking for goes towards 0. So we just look at 1.2 and it will be the same with the negative 1.2. So this is 1.2. Since the hundredth digit is 0, we just look at 0. So the area of 1.2 is 0.3849. Therefore, the area of this region is 0. What was that? 3849. So 0.3849. So this area here between 0 and negative 1.2 is 0.3849, while the area between 0 and 0.75 is 0.77.34. What does this mean? It means that those people who scored with z equals 0 up to z equals 0.75 is only 27.34%, while those people who scored from negative 0 up to negative 1.2, that's the corresponding z-score, the population is 38.49% only. So that's how we go around in interpreting the data. So there are other things that we can analyze in this particular z-score. We can analyze z-scores between two scores, or we can analyze a z-score above a particular z-score or below a particular z-score. Just remember that if we are going to use this table, it has to be the area going towards 0. If not, we can just apply subtraction. Like, for example, what if I'd like to determine the area above 0.75, this area that I'm shading right now? How would I get the area above 0.75? Simply just get this area, in this entire area, minus this area here. Since we know that this is 0.2734, to get this area here, what we just have to get is get this particular half area here. Remember that this 0.5, that is same ano. Remember that the entire normal curve is 1, so the half is 0.5. Then subtract this blue area here, that's 0.2734. And this is equal to, let's subtract, 0.5 minus 0.2734. And this is equal to 0.2266. 0.2266. So in order for us to get the area above 0.75, we just have to make subtraction. So this area here is 0.2266. What if I'd like to get the area between negative 1.2 up to 0.75? Just simply add the two areas. So in order for us to get the area between two scores, we just have to perform addition or subtraction. It depends on the position of the z-score. So it's always best that we have to illustrate the area first before we apply the table of areas under the normal curve. So in this scenario, we have to apply addition. That's 0.2734 plus 0.3849. So that would be plus 0.3849. The area would be 0.6583. So I hope you guys learned a lot today. Thank you guys for watching and see you guys on the next video.